All right, boys and girls, let's talk about one of our last lessons for division, and that is what's known as interpreting remainders. Um, I feel like interpreting remainders, at least this is kind of what I tell my students, can sometimes be one of the more trickier parts when it comes to division. And a lot of times it's because you're dealing with math, you're having to go and do something that's could be difficult. A lot of kids struggle with division until they get it down and they get the practice. So that part of it is tricky. But then you're really kind of bringing in a lot of reading and analyzing problems to truly understand what a remainder means and what it means for a specific problem. So I'm going to first show you a few things on this page. First, let's look at the problem on the left. So here lately, you guys have probably just been doing lots and lots of computation practice, which basically means it's just straight math. You go work a problem, you're trying to find out what the quotient is, or possibly what the quotient is and how many are left over, or if it has a remainder. And so, what I like to do is I like to have this conversation with my students, like when we start interpreting remainders, is okay, well, if we go solve a problem and we get a remainder, well, what does that mean? And so, let's just look at this problem on the left side of the page here. So, this is 1,215 divided by 12. So, this would be a 4 by 2 division problem. This would be one of the ones that we would expect you guys to know as fifth graders. And so if we went through this problem, again, going through your steps, does McDonald's sell cheeseburgers? You'd start with, division and how many times can 12 go into, and then you'd start going, through your number, whatever it might be. In this case, it's 1,215. So my first step that I would ask my students is, well, 12 can't go into 1, so how many times can 12 go into 12? And so I would start this problem with, well, it could go in one time. And so we can multiply 12 times 1 is 12. We're going to now get to the subtraction step. 12 take away 12 is 0. And so this one would be one that's unique because when you bring down the 1, 12 is greater than 1. And so this would have to be one of those problems where you have to have what's called a 0 in the quotient. And so I always tell my students, it's kind of just a good rule to remember in your mind. When something comes down, when you bring down a digit, something has to go into the quotient. So if I'm going to bring down a digit here, something has to go up. And the only thing that could go up is a 0. And that's because 12 is greater than 1. Well, 12 times 0 is 0. We're going to subtract again. We're going to get the 1, but now we have it to where we can bring down the next digit. And so now we're taking 12 into 15. And so that step's kind of tricky, so watch for that. Those are called zeros in the quotient. Those will happen every now and then. They don't happen on every problem, but they do happen occasionally. And so this very last step would be, how many times can 12 go into 15? Well, since 12 and 15 are so close on the number line, it can't go in but only once. And then we'd have 12 at the bottom. And then you would subtract there, and then you would have a remainder of 3. So let's talk about this problem. Let's talk about remainders. So we got a remainder on this problem, and the way I kind of teach my students is, well, now if I'm looking at what I just did and I have my answer is 101 with a remainder of 3. If I ask my students, well, hey, can we interpret this remainder? My conversation with my students would be, well, yeah, it's a remainder and it's left over, but technically we can't really interpret what that means because we don't have a word problem that we're looking at. I mean, basically, this is just a straight math problem. We're just trying to find out how many times 12 can go into 1,215. And so if we have a remainder of 3 at the end, I really can't interpret that. I can't, break this down and truly understand, well, what does that remainder 3 mean? I don't know, is this talking about rocks? Is it talking about baseball cards? Is this talking about video games? I mean, I don't know. And so at this point, your remainders that you've been seeing, you probably haven't interpreted those too much. But the lesson of interpreting remainders is when you're reading a word problem and you're breaking it down and you understand, okay, at the end I do have a remainder. You have to sometimes understand what to do with that remainder. And so there's a graphic kind of on the right side of the screen here, and it's something that we use. The fifth grade teachers use this quite a bit to teach interpreting remainders. And I know it's kind of sideways or upside down in some places, but I think if you turn your iPad or turn your head, you could read what it's saying. And basically, what is it's telling you here is there's 5 ways to interpret a remainder, and there's probably going to be a few that are a little bit more popular in fifth grade than a couple of these. But it basically it all means the same thing. It means when you solve a problem and you get a remainder at the end, you solve a word problem. You've got to know what's what. You got to know. Okay, if I truly do get a remainder, then what does that remainder mean? What does it stand for? What is it talking about? And so again, at the very first part of this video, that's what I was saying, that it gets a little trickier for kiddos because you really are bringing in a lot of reading skills. It's not just your math that you're having to deal with. You're bringing in a lot of reading skills when you do this. And so we're going to practice a few of these. As you could tell on this graphic on the right, there's some ways, if you were to get a remainder, what that can mean for you. And so I'm going to kind of go around this little graphic and then we're going to try some. So one of them says, if you look at the bottom left corner of the picture there, it says just drop it. And it says if the remainder is unusable, well, that could be the case sometimes. Sometimes you might be working a word problem and that remainder means nothing. You just need the quotient, basically. So like on the problem over here to the left that we worked, maybe 101 is truly your answer. If you look to the bottom right corner, it says when asked how many are left over. Sometimes questions, that's what they want to know is, well, okay, how many were remaining? And so on this problem on the left, it could be they're asking about that 3. Again, we don't know what that 3 means because it was just a problem. We didn't have a word problem to look at. If you look at the top right says if more are needed, it says round up. So that I always tell my students there's kind of a classic problem that goes with that one, and a lot of students probably hear it and practice this one in 4th grade, and it's the one where maybe you are like going on a trip or something and you need like so many buses to take people somewhere, and you're sitting there and you're like, okay, I've got to get so many buses to take all these people, and then I work the problem and I have 3 left over. And okay, well, those 3 just don't get to go, or do we need to order another bus? And so you add one more to your quotient. So you round up, you add one more. And so that's one that happens occasionally. And then the last one is actually in the top left corner. That's the one where, in my opinion at least, I feel like we don't see this all that much until we get to maybe fractions, which is going to come later in the year. But it's saying to change the decimal into change the remainder into a fraction, or to change it into a decimal. And that is going to occur at some point in your life, that you are going to be thinking about that. But right now, I would say for where we're at in 5th grade, probably those other 3 that I just went over with you are the ones that are a little bit more popular. So I'm going to kind of circle those, the ones that I'm referring to. These are the ones that I think you're going to see more of right now. And so when you're problem solving and you're reading, you gotta kind of stop and think, okay, is it going to be one of these options where are they just looking for the remainder? Are they just looking for the quotient? Or maybe is it one where you have to like bump up your quotient by 1? All right, so let's try a couple. All right, so on this next page, This is just a problem that I pulled from one of our activities. I thought I'd go over it with you guys. We do a little problem solving together, and then we talk about remainders and what they truly mean. Okay, so this problem reads, the book was 141 pages long. Sam read the same number of pages each day for 8 days and finished the last few pages on the 8th day. How many pages did he read each of the 8 days? And then it says, not including the last few pages. What does the remainder represent? Okay, so on this problem, this is kind of how I would break it down. And a lot of times when you're reading these problems and you're really, analyzing them and thinking about what to do, you always go back, you reread, you think about, what are they giving me? What's the information that's important? What's maybe the information that's not important? And then, of course, your question is extremely important. So I would probably start with the book that gave you basically gave you a total here. They're saying that the book is 141 pages long. And then he goes and he reads some, and it says he reads the same number of pages each day for 8 days. So I know that about Sam. And then on the last day, it says he finished the last few pages on the 8th day. And then it goes into our question here. So I always make my students put brackets around the question. I feel like, that's kind of your focal point after you reread it. You need to really focus in on what do they want. So how many pages did he read each of the 8 days? And then it says not including the last few pages. Okay, so let's see what happens here. I'm going to move the page a little bit. Let's see if I can move it down. I'm going to create myself some room here. So I feel like this problem could turn into 141 divided by 8. Okay. So let's think about a couple of things on this problem. First of all, on this problem, this is what would be known as a 3 by 1. This is an easier division problem because you're dealing with a one-digit divisor. That's a 4th grade problem, really. And I would also maybe test my students and say, well, even though it's, we're talking about remainders here, I still would test them and ask them, well, how do you know that this is going to give you a remainder? And I would hope that their response would be, well, if you look at this problem, if you know your 8s, there's no multiple of 8 that's going to give you an odd number. All your 8s are even numbers. So if this is 8 going into 141 is an odd number. So you just know you're supposed to get a remainder here. Okay, so let's solve. So 8 can't go into 1, but 8 can go into 14 one time. And I'm going to keep moving the screen down a little bit. Here we go. Okay, and so now I'm going to go back. I'm going to subtract. 14 take away 8 is 6. I'm going to compare. 6 is less than 8, so I'm still good there. I'm going to bring down the next digit. And so now I'm looking at how many times can 8 go into 61. And so if I know my facts of 8, this is usually a tougher one, but 8 times 7 gives me 56. 8 times 8 gives me 64, so it's too much. And so I'm going to take it in 7 times, and I'm going to have a difference here of just 5, looks like, because 61 take away 56. I'd have to regroup there. It looks like 11 take away 6 is going to be 5. So on this problem, if I go back to what it's talking about and what what this problem really represents here. Let's see if I can get it up here. Yeah. So going back, I know that the book is 141 pages long. And I know that he read the same number of pages for 8 days, because that's how long he was reading. And then it says, and finished the last few pages on the 8th day. And then it says, how many pages did he read each of the 8 days, not including the last few pages? So on this problem here, I feel like if he's reading for 8 days, that, truly, if I break this down and I really think about what's happening, my quotient here, my 17, is how many pages did he read each of the 17 days? I think that that's really what they're talking about. And then it says, well, what does the remainder represent? And so my remainder here is 5. I think those 5 pages might have been the last few pages that they're referring to. So, like, if he's reading the same number of pages every day, and then he goes and he's going to read 17 every day, then that's going to put him close to 141. And then the last day, they mentioned that, okay, he's got a few pages left. And I think that 5 that's left is that little bit, basically at the end of his book that he hadn't read, but those are those last few pages that he had to read. So this question's kind of, in my opinion, they're kind of asking a couple of things here. How many pages did he read each of the 8 days? I think he read 17. But then it says, well, what does the remainder represent? I think the remainder on this is just those last few pages that he had to read. And so not every question is going to look like this, but this is one where you're having to break it down and really think about not just a division problem, but what does your answer represent? What's your quotient represent? What does your remainder represent? Okay, this next problem says Sophie's mom is putting photos from Sophie's first Halloween into a scrapbook. A scrapbook page can hold 7 pictures. She has 66 photos. How many pages does she need to fit all the photos? Okay, so on this problem, it's kind of the same thing as the last one. I'm going to start with my brackets at the end. I'm going to reread that question. How many pages does she need to fit all the photos? I think that's going to be an important part for us right there. It says that she has 66 photos, so there's my total. And then a page can hold 7 pictures. And so I think this is going to be a pretty basic division problem, but the end of this could be a little bit tricky if you don't know how to interpret the remainder. Okay, so this right here is just going to be a math fact. I mean, if you know your sevens, this would be extremely easy, pretty quick division problem because it's a 2 by 1, so it's just a math fact. So how many times would 7 go into 66? If you know your math facts, you would know it would be 9. 9 times 7 is 63. You're going to have a leftover of 3. And so your answer here is going to be 9 with a remainder of 3. But again, it's kind of like, well, when you look at this, I have to understand everything about what I just did. And so a strategy could be, I always make my students do this, especially when we get to interpreting remainders. I make mine label everything. And usually there's 4 things to label. So I'm going to start with all 4 of my numbers in my problem. And so I have a 66, I have a 7, I have a 9, and I have a 3. And I always tell them the dividend and the divisor are always really easy to label because they give you that in the, in the problem. 66, that's how many photos she had. So I'm going to write photos here. A page can hold 7 pictures. So I'm going to put page, and then I'm going to put a slash here, and I'm going to put 7 pics. Okay, now the 9 and the 3 aren't in the problem, but you have to interpret those things. You have to understand what those things mean. And so for this problem, I think what has to happen, or when you go back, maybe you have to read it again to truly understand what she's doing. But I think what's going to take place on this one is if I go back to the question, how many pages does she need to fit all the photos? I think the 9 is these are the ones that she's going to fill up. These are the full pages. In other words, these are the ones that are going to have 7 pictures on a page. So I'm going to put full pages here. In other words, when she flips through this scrapbook, those 9, there's going to be 9 pages there that have 7 photos on it. The 3 would be, okay, if I were to really think about this, I think those are going to be leftover pictures that didn't make like a full page. So in other words, it's like she's going to have 9 full pages, but then these 3 would be leftover pictures. So I'm going to write that as leftover pics. Well, at this point, now I have to kind of stop and think, well, what did they want again? So I'm going to go back over here to my question. How many pages does she need to fit all the photos? Well, if I really think about this, a lot of kids would probably go with 9 because when they do the problem, they see that 9's the quotient. They get excited because they get, they figured out their division problem here and they're like, okay, great, I think I get it. But the reality is, I don't think it's going to be 9. I think it's going to be one more. So this would be one like from earlier when I was talking about sometimes you have to bump up your quotient. This would be that bus example that I was talking about. This would be one where you have to bump up your quotient by 1. So I actually think 10 pages is really what they're looking for here. And that's because that 10th, think of it this way, that 10th page is not going to be full of photos. But to fit all the photos on there, she has to have that 1 extra page. So this is one where you're going to have to kind of just bump up the quotient. So be careful with those. So those can be a little bit tricky. But I feel like if you're a student and you truly understand the problem, if you label everything and it makes sense to you what you're reading, then from there you can justify your answer and you can go, okay, well, I've given them what they wanted here. They wanted to know how many pages total to fit all the photos. Well, it's going to take 10. 9's not going to do it. I'd have 3 photos there. What am I going to do with those? Am I going to just throw them away? No, you're not going to throw those away. You need them for another page. Okay, last one here. Christy is organizing her music on her iPod. She wants to put 6 songs on a playlist. She currently has 98 songs. How many complete playlists can she make? Okay. Let's think about this one again. What they want. How many complete playlists? I think that's going to be important. How many complete playlists can she make? This is still one. If you're breaking down, a lot of division problems are set up this way. You're given a total. There are 98 songs. And she wants to put 6 songs on a playlist. So it's almost that mindset of they gave me a total, and then they gave me a part, and so now I'm going to take the total of 98, and I'm going to go see. All right, you can always maybe think of it like in groups. So I want to go put them into 6 groups. So there's going to be 6 songs on a playlist. So I could break them apart, and I could think a little bit about part whole here. So I have a total, and then I have a part, and then I'm going to go figure out the other part. So again, 98 divided by 6, this would just turn into math facts possibly, or it could just turn into a very simple division problem. Since your biggest math fact for a 6 should be 12 times 6, that should be the one that you should know and have memorized by 5th grade. 12 times 6 is 72, so I'm close to where I need to be, but I'm probably just going to go ahead and solve this one traditionally. So 6 can go into 9 one time. I'm going to write my 6 underneath. I'm going to subtract. I'm going to compare and bring down. And then I'm left with how many times can 6 go into 38. I can get close with 6. 6 times 6 is 36. I'm going to have 2 left over. And so I'm going to have this answer for my problem of 16 with the remainder of 2. Okay, but that's not what they want. They want you to dig a little bit deeper here on this problem. So I'm going to read the question again. How many complete playlists can she make? All right, well, let's practice it again. Let's think about what our 4 numbers are. We have 98, we have 6, we have 16, and then we have 2. Okay, so I know that she has 98 songs. I know that she's going to put 6 songs on a playlist. So I'm going to put songs, and I'm going to put a backslash here, and I'm going to put playlist. And then I have these other two numbers that I don't know about yet. But if I think about it, I think I could probably figure out what 16 and 2 go for. Okay, so the 16. Um, if I really think about what this problem is talking about, a playlist, basically it's just a group of songs that you want to go listen to. And if she's going to put 6 songs onto a playlist, then a playlist, when she creates that, I think she can create 16 of those. And if she gets 16 of those created, that's going to take care of quite a bit of her songs. So I think the 16 go for either, you could write it a couple different ways. You could write like full playlist, or you could write complete playlist. So I'm going to write full playlist. I think the 2 here are the songs that can't go onto a playlist. So in other words, they're my leftover songs. They're the songs that kind of get just left out. And so I'm going to write leftover songs. So this is what you can't put onto a playlist. And so now that I have everything labeled, I could go back to what do they want? How many complete playlists can she make? Well, I kind of answered that when I was doing my labeling. Basically, she can only make 16. This is really my answer. This is what they want. The 2 songs that are left over, to make a complete playlist, she has to have 6 songs. Well, she had those 2 left over, so she can't make the 17th playlist. She can't make another one. So if they want to know how many complete playlists can she make, then I really want what's known as the quotient. I want to basically just drop the remainder. The remainder is not important for this question. Now, how they had, you can always pretend, well, maybe they ask how many songs are left over. Well, then, of course, yes, 2 would be your answer. But in this case, they didn't want that. You have to go and, again, really think, what do they want? How many complete playlists can she make? Well, she can only make 16. And so as you go through these problems, as you really get into division and you think about breaking them down and analyzing them, you really have to stop and think, what are all these little parts and pieces that they're giving me? A lot of times students won't do that. They won't sit and take the time to label those parts. But if you do it and you think, to me at least, it makes more sense. And it really helps you truly, understand what you're reading, what you're solving, because, you can go and do a division problem all day long. That's great if you can do it. But if you get to a word problem and you don't know what you're doing and, you're just throwing together something and basically at the end they're going to ask you that question, you may not know what to pick. And so it just takes a lot of practice. It takes you paying attention, and you got to really focus in on what they want. And again, I always warn my students, hey, if it's a word problem and it's going to be a division word problem, you got to really start thinking about interpreting a remainder. Not everyone's going to have a remainder. Sometimes you'll get questions that, basically you don't have a remainder at the end and everything works out fine and, everything goes in equally. But when that remainder pops up, you got to really know what they want.